Welcome everyone to this video. Today we're going to be talking about differentiation, which is very fundamental to most of the STEM careers, right? So engineering, mathematics, sciences, technology as well, right? So what is differentiation? Differentiation is all about finding the rate of change of a function with respect to a variable, right? So this is actually the dy dx, and it's pretty much seen as the change in y relative to the change in x. So this is something we know very well because it's the same as what we've seen previously, which is the gradient, or sometimes the slope. So if we have a function y is equal to f of x, right, which is equal to ax raised to the power n, then my dy dx, which is actually a differentiation of the function, is actually equal to n a x n minus 1. This is the standard formula for differentiation, and it's worth noting. So many people I know of sometimes struggle with this, right? So it's something that you have to really know, and the only way to remember this is if you've solved so many problems using this formula, right? And we'll see some of those kinds of problems you can solve using this formula. So anytime you have a function that is equal to a times x raised to the power n in a polynomial form, right, like that, then the differentiation dy dx is equal to n a x n minus 1. Okay, so let's see if this makes sense, right? So let's see. So you remember that a linear, so for typically when you have a linear graph, right, it's represented in the form, so let me say linear equation. In some situations we're looking at it as a graph, right? It's represented in the form y is equal to mx plus b, right? Interesting. So of course, where you're looking at it as if that's my y is equal to mx plus b, right? And of course this here is the intercept, right, b, right? So let's see, if you try to find dy dx for this equation, let's see what we get in this case. Okay, applying the formula above, right? Now we'll take it bit by bit. We'll take this part first, and then we'll take the b part second, right? So let's go first with the mx. So if we apply the formula, you can see clearly that in this case, when we're looking at the mx, right, my a is equal to my m, and my n now itself is equal to, if you look at that very well, it's going to be equal to 1, right? Okay, good. So if we do that to the mx part of it, we're just going to have n times a is going to be my 1 times my m, right? X raised to the power 1 minus 1. Okay, good. Plus, if we look at the second part of it, so this is just for the mx part of it, right? Let's look at the b part of it now and see what happens. Of course, b is the same thing as saying, oh well, it's just the same thing as saying it's b x raised to the power 0. All right, very good. So that means my a in this case is going to be my b, and my n in this case is going to be 0. So let's try it out now. So if we do that, applying the formula we have above, we're going to get my n is going to be 0 times my a in this case is going to be b times my x raised to power n, which in this case is 0 minus 1. Of course, 0 times anything gives you 0. So that means I'm going to be getting my m x raised to power 0, which of course is going to give me my m. That makes complete sense, right? Because we know that the slope of a line y is equal to mx plus b has to be m, right? So that makes complete sense. Okay, now let's see an example of how to solve this problems now in differentiation, right? So let's take an example now. So example 1. Let's see what happens now. So it says find dy dx if my y is equal to 3x squared. So solution to this problem, let's see what we get from this. So if I do this correctly, I'll say, okay, well, that's fine. I have my y to be equal to 3x squared. Therefore, clearly, if I look at this and compare that with ax raised to power n, my a in this case is going to be 3, and my n in this case is going to be 2. So therefore, my dy dx is going to be, so if I differentiate that, it's going to be my n a x n minus 1, which is going to be n in this case is 2 times my a is 3 x raised to power 2 minus 1, since my n is 2, right? So that's going to give me my 6x. That's the answer to this problem if I differentiate the function y is equal to 3x squared. So I hope this is clear, but if it's not, let's look at a second example now, right? So let's move in and see a second example now. Okay, I'll just clear this. So let's look at an example 2 now in this case. So it says find dy dx if my y is equal to 3. Interesting. So let's look at the solution to this problem now. So clearly, in this case, my y is equal to 3. If I do a little bit of rearrangement there and trying to make it as a function of x now, I should be getting that my y is equal to 3x raised to power 0, because anything raised to power 0 is 1, right? So x raised to power 0 is 1. Very good. So that means at this point, I can see my a is equal to 3 and my n is equal to 0. So therefore, my dy dx is going to be n a x n minus 1, which in this case my n is 0, so I'm going to get 0 times my a is 3. I'm going to have x raised to power 0 minus 1. Of course, this is going to give me 0. Does this make sense? Let's see. So if you plot a graph, typically a graph of y versus x now, and we just have a constant graph just going all the way like that. So, and this value here is 3. So if you look at it, if it's just a flat line, right, definitely you can see that the slope in this case should be equal to 0, and that's exactly what we got. So that makes sense. Okay, now let's look at another example now. This time around, let's make it a little bit complicated, right? And see, again, it's really easy if you understand differentiation. Let's look at example 3. It says, find dy dx if my y is equal to 3x cubed plus 6x plus 3. So in this case, what do? First, I always advise that you kind of transform this so that all of the values, in the function itself is a function of x, is attached to x, right? So we're going to have 3x cubed plus 6x raised to power 1, of course, right? Plus 3x raised to power 0, because anything raised to power 0 is 1. So if we know this now, let's bring out dy dx. Let's find out what our dy dx is going to be. Of course, this is the solution, right, to the problem. So let's find out what our dy dx is going to be. Of course, if we apply the formula here, it's going to be, we're applying the formula. Okay, I'll write the formula somewhere there so that we always remember. So dy dx is equal to nax n minus 1. So if we're applying the formula to this first value there, we're going to have, in this case, our n is 3, our a is 3. So we're going to get 3 times 3 x raised to power 3 minus 1. That's the first part. Plus, where we have 6x raised to power 1, it's going to be again 1 times 6 x raised to power 1 minus 1. Plus, we're going to have 0 times 3 x raised to power 0 minus 1. Just like the previous one we did before. Excellent. So if we do this correctly, what are we going to get? We're going to get 9x raised to power 2 plus we're going to get 6x raised to power 0 plus 0. And of course, this is going to give us 9x squared plus 6 as the final answer. Interesting. That's the final answer. Okay. So this is also actually, this is example 3, right? So let us now see what happens now, because not every time we're going to have a polynomial that is kind of straightforward. Let's see, what if we have two polynomials multiplying themselves? What is going to happen in that situation? Actually, oh sorry, this is actually example 2. My mistake there. This is example 2. And that is example 3. So let's see what happens now if we have two polynomials that are multiplying together, right? And let's see what happens in that case, right? So that's what we refer to as the product rule. So I'll clear this. So we call that situation when two polynomials are multiplying, the product rule. So I'll just write it down very quickly. The product rule. It's actually an interesting, very, very interesting rule. I like to apply that a lot. So let's see, we have, if we have y is equal to uv, right? Then we're saying that dy dx is going to be equal to v du dx minus u dv, plus actually u dv dx. So let's see an example now of how this works. Let's look at an example. So in this case, we're going to call it example. We're just looking at the fourth example actually. So the fourth example. So it says find dy dx if my y is equal to x cubed times, which is, in this case, we're just using a dot now, x squared. So if we look at this properly, we're going to see that this going to give us, of course, this of the form y is equal to u times v. So that means my u is equal to x cubed, and my v is equal to x squared. Okay, if we know this now, let's see if we can kind of differentiate that function now. So if we do that, so my dy dx is going to be equal to, again, we're applying the product rule, v du dx plus u dv dx. So if we do that correctly, what are we going to get? V in this case is actually x squared. Du dx is actually x. So it's going to be 3x squared, right? Okay. Plus u now in this case is x cubed. But we have to now differentiate v now, which is going to give us, if we differentiate that, we're going to get 2x, right? Applying the formula again, this formula is just applying n minus 1 to get the differentiation of these ones. So if you do that correctly, what are we going to get? So we're going to get 3x raised to power 4 plus 2x raised to power 4, right? So this is going to be the same thing as 5x raised to power 4. And that's the answer there. We've got the answer. Okay, now you might say, this seems interesting. Okay, is there a way to confirm it? Yes, we can actually confirm it. Let's do a quick check to see whether this formula is actually very, very correct. Okay, we know that the original function was y is equal to x cubed times x squared. If we do that correctly, remember the laws of indices, right? So it's going to be x cubed plus 2, right? Which is going to be x raised to power 5. All right, if we know this, can we look for dy dx of x to the power 5? So let's see. If we do that correctly using n minus 1, we're going to get 5x 5 minus 1, which is going to give us 5x raised to power 4. Of course, this is the same thing as what we just got now. These two are the same. Okay, good. We've been able to prove that that works for sure. All right, now let's proceed now to see one other method now that is one other approach that is very important as well for engineering, technology, sciences, as well as mathematics. And that rule is actually called just the quotient rule. So again, a very interesting rule. I like it so much and I utilize it a lot. So it says that if my function is y is equal to u over v, then we're saying that my dy dx is going to be equal to my v du dx minus my u dv dx divided by my v squared. Okay, just have to extend this. All right, so again, it looks a little bit complicated, but it's not. Let's look at an example to kind of understand this. So let's look at an example. So example, in this case, it should be example 5 now. So let us say we were told to find dy dx if y is equal to x raised to power 7 divided by x raised to power 3. So in this case, of course, if you look at that and compare that to u over v, you would see that my u is equal to x raised to power 7 and my v is going to be equal to x raised to power 3. Okay. All right. If we know this now, let us find the solution to this problem. Let's find dy dx now. So dy dx is going to be equal to v, applying our formula v du dx. V in this case is x raised to power 3. Du dx is actually going to be differentiating u, which is x raised to power 7. It's going to give us 7 x raised to power 7 minus 1, which is actually in this case 6, minus u dv dx. U in this case is x raised to power 7, and multiply by dv dx. Dv dx is just going to be differentiating differentiating v with respect to x. So it's going to be 3x squared, right? Okay. Divided by v squared, which in this case is going to be v squared is going to be x raised to power 3 all squared. Okay, good. So if we do that, what do we get? So if we multiply through, we're going to get x raised to power 3 times x raised to power 6. Of course, it's going to give us x raised to power 9, right? 7 times x raised to power 9 minus, if we multiply through, we're going to get 3x raised to power 9 as well for the second part, divided by x raised to power 6. Of course, if we subtract these two, they're the same, like terms, right? So we're going to get 4x raised to power 9 divided by x raised to power 6. So this is the same thing as 4x raised to power 9 minus 6. Of course, this is going to give us 4x raised to power 3. All right, that's, if we apply the quotient rule, that's what we get. Now, okay, good, interesting. Let's see, is there a way to check if this is the case? Let's see. So we know that x raised to power 7 divided by x raised to power 3 should be x raised to power 7 minus 3. So that should give us x raised to power 4. All right. So if we differentiate now dy dx for this x raised to power 4, we're going to get 4x raised to power 4 minus 1, which is going to give us 4x raised to power 3. Of course, this is the same thing as we just got just a moment ago. So that makes complete sense that the quotient rule is actually correct. So again, it's a brief summary of differentiation of polynomials. We use that a lot, as I mentioned before. So it is important for you to have a feel of it and understand it for sure. So thank you very much for watching, and I'll see you in another video.